To effectively protect the pump controller from voltage surges, surge suppression devices should be installed on both the 480 volts feed and the 120 volts output of the transformer. There are several reasons for this. Firstly, surges entering through the 480 volts feed can damage the transformer or equipment connected to the secondary side, including the pump controller. Secondly, surges on the 120 volts output can directly damage the pump controller. Ensuring that the secondary side of the transformer is properly grounded is crucial for surge protection. A good ground provides a low resistance path for surge currents to dissipate, reducing the risk of damage to equipment. For the 480 volt surge suppressor, install a Type 2 surge suppressor rated for 480 volts 277/480Y and the appropriate current rating. For the 120 volt surge suppressor, install a Type 3 surge suppressor rated for 120 volts and the appropriate current rating. Consider using a surge protector with a surge capacity that exceeds the maximum expected surge current. Inspect the surge protectors regularly to ensure they are functioning properly. If possible, relocate the pump controller and transformer to a location that is less exposed to surges. Ensure that the electrical grounding system for the entire installation is adequate and up to code. When dealing with submersible pumps and their control systems, the risk of electrical surges, particularly during storms, is a significant concern. These surges can originate from various sources, including lightning strikes, utility grid switching, and even internal equipment malfunctions. Protecting sensitive electronic components like pump controllers requires a comprehensive approach involving surge protection devices, proper grounding, and adherence to electrical codes. The primary goal of surge protection is to divert or suppress transient overvoltage events before they can damage equipment. These transient voltages, or surges, can be many times higher than the normal operating voltage, and they can occur in microseconds. Without adequate protection, these surges can lead to immediate failure or gradual degradation of electronic components. When it comes to protecting pump controllers powered by a 120 volts transformer fed from a 480 volt source, a multi-layered approach is recommended. This involves installing surge protection devices both on the 480 volts side and the 120 volts side of the transformer. Let's examine the rationale behind this strategy. Surges can enter the system through the 480 volts feed. These surges can propagate through the transformer and into the secondary 120 volt circuit, potentially damaging the pump controller. Installing a surge protection device on the 480 volt side helps to intercept these incoming surges and prevent them from reaching the transformer. Even if a surge doesn't originate from the 480 volt side, surges can also occur directly on the 120 volt circuit. This could be due to local events or induced voltages. A surge protection device on the 120 volt side provides a last line of defense, protecting the pump controller from these direct surges. Grounding plays a vital role in surge protection. A properly grounded system provides a low impedance path for surge currents to flow to ground, minimizing the voltage stress on equipment. In the case of a transformer, it is crucial to ground the secondary side. This creates a reference point for the 120 volt circuit and helps to stabilize the voltage during surge events. Without a proper ground, the voltage on the 120 volt side can float, increasing the risk of damage. The National Electrical Code, or NEC, provides guidelines for grounding transformers. Typically, this involves grounding the neutral point of the secondary winding. The specific requirements depend on the transformer configuration and the type of system. Consult NEC Article 250.30 for detailed information on grounding requirements for separately derived systems, which includes transformers. When selecting surge protection devices, it's essential to choose the appropriate type and rating for the application. Surge protection devices are classified into different types based on their location in the electrical system and their surge handling capabilities. Type 1 surge protection devices are typically installed at the service entrance. Type 2 surge protection devices are installed at distribution panels or subpanels. Type 3 surge protection devices are installed near the equipment being protected, such as the pump controller. For the 480 volt side, a Type 2 surge protection device is generally recommended. It should be rated for 480 volts and have a surge current capacity sufficient to handle expected surge levels. For the 120 volt side, a Type 3 surge protection device can be used. It should be rated for 120 volts and have an appropriate surge current capacity. The surge current capacity is measured in kiloamps, or kA. High kA ratings indicate a greater ability to handle large surges. The selection of the appropriate K rating depends on factors such as the location of the equipment, the exposure to lightning, and the characteristics of the electrical system. In areas with frequent lightning activity, higher K ratings are generally recommended. In addition to surge protection devices and grounding, there are other precautions that can be taken to minimize the risk of surge damage. Firstly, ensure that all wiring connections are tight and secure. Loose connections can create points of high resistance, which can exacerbate surge effects. Secondly, consider using shielded cables for sensitive control circuits. Shielded cables can help to reduce the amount of electrical noise and interference that can couple into the circuit during a surge event. Thirdly, install surge protection devices on all incoming power and signal lines. This includes telephone lines, data lines, and any other conductive paths that could carry surges into the equipment. Fourthly, regularly inspect surge protection devices to ensure that they are functioning properly. Some surge protection devices have indicator lights or other means of signaling when they have been subjected to a surge and need to be replaced. Fifthly, if possible, relocate sensitive equipment to a location that is less exposed to surges. This could involve moving the equipment to a different building or to a different part of the building. Sixthly, ensure that the electrical grounding system for the entire installation is adequate and up to code. A poor grounding system can compromise the effectiveness of surge protection devices and increase the risk of damage. It is important to note that surge protection devices are not a substitute for proper electrical installation and maintenance. They are a supplement to these practices. A well-designed and properly installed electrical system is the first line of defense against surges. In addition to protecting against surges, it's also important to protect against other electrical hazards such as overcurrents and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. These devices can help to prevent damage to equipment and reduce the risk of fire. Short circuits can occur when there is an unintended connection between two conductors. Short circuits can cause a large amount of current to flow, which can damage equipment and create a fire hazard. Ground fault circuit interrupters, or GFCIs, are designed to detect ground faults and interrupt the flow of current. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas, where there is a risk of electric shock. Regular maintenance is essential for ensuring the continued reliability and safety of electrical equipment. This includes inspecting wiring, tightening connections, testing surge protection devices, and replacing worn or damaged components. A qualified electrician should perform electrical work. Electrical work can be dangerous, and it should only be performed by individuals who are trained and qualified to do so. Working with electricity can be hazardous if proper safety precautions are not taken. Always to energize circuits before working on them. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Follow all applicable electrical codes and safety standards. In summary, protecting pump controllers from voltage surges requires a comprehensive approach that includes surge protection devices, proper grounding, and adherence to electrical codes. Surge protection devices should be installed on both the 480 volts feed and the 120 volts output of the transformer. The secondary side of the transformer should be properly grounded. Regular maintenance and inspections are essential for ensuring the continued reliability and safety of electrical equipment. In addition to the points previously mentioned, it's crucial to consider the specific environmental conditions in which the pump controller and transformer are located. Areas prone to frequent lightning strikes or extreme weather events may require more robust surge protection measures. Furthermore, the type of equipment connected to the electrical system can also influence the selection of surge protection devices. Sensitive electronic equipment, such as variable frequency drives, or VFDs, may require more sophisticated surge protection than less sensitive equipment. When selecting surge protection devices, it's important to consider the let-through voltage. The let-through voltage is the maximum voltage that the surge protection device will allow to pass through to the protected equipment during a surge event. Lower let-through voltages provide better protection. However, surge protection devices with lower let-through voltages may also have lower surge current capacities. It's important to strike a balance between let-through voltage and surge current capacity to achieve optimal protection. Another important factor to consider is the response time of the surge protection device. The response time is the time it takes for the surge protection device to activate and begin diverting surge current. Faster response times provide better protection. However, surge protection devices with faster response times may also be more expensive. When installing surge protection devices, it's important to follow the manufacturer's instructions carefully. Incorrect installation can compromise the effectiveness of the surge protection device and may even create a safety hazard. Surge protection devices should be mounted in a location where they are easily accessible for inspection and maintenance. The wiring connections to the surge protection device should be tight and secure. The surge protection device should be properly grounded. After installing surge protection devices, it's important to test them to ensure that they are functioning properly. Some surge protection devices have built-in testing capabilities. Others may require the use of a separate tester. Regular testing of surge protection devices is essential for ensuring that they will provide adequate protection when needed. In addition to surge protection devices, transient voltage surge suppressors, or TVSS, proper grounding, and adherence to electrical codes, it's also important to educate personnel about the risks of electrical surges and the importance of surge protection. Personnel should be trained to recognize the signs of surge damage and to take appropriate action. They should also be instructed not to disconnect or bypass surge protection devices. Surge protection is an ongoing process, not a one-time event. Surge protection devices should be regularly inspected and maintained. Damaged or worn surge protection devices should be replaced promptly. The electrical system should be periodically inspected to ensure that it is up to code and that all components are functioning properly. By taking a comprehensive approach to surge protection, it's possible to significantly reduce the risk of damage to pump controllers and other sensitive electronic equipment. This can help to improve the reliability and uptime of pumping systems and reduce maintenance costs. Remember, a proactive approach to surge protection is always better than a reactive one. Don't wait until a surge event damages your equipment to take action. Implement surge protection measures now to protect your investment and ensure the continued operation of your pumping systems. Finally, remember that electrical codes and standards are constantly evolving. It's important to stay up to date on the latest requirements and best practices for surge protection. Consult with a qualified electrician or electrical engineer to ensure that your surge protection system is properly designed and installed. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before making any changes to your electrical system. Protecting your electrical equipment from surges is a crucial investment in the longevity and reliability of your systems. By implementing the strategies outlined here, you can minimize the risk of damage and ensure the continued operation of your essential equipment. The NEC Article 280 covers surge arresters over 1000 volts. Also, be aware of the differences between surge protection devices and surge arresters. While both serve to mitigate voltage surges, they are designed for different voltage levels and applications. Surge protection devices, often referred to as TVSS, are typically used in low-voltage systems such as the 120 volts and 480 volt circuits discussed earlier. Surge arresters, on the other hand, are primarily used in high-voltage systems such as those found in utility substations and transmission lines. Surge arresters are designed to handle much larger surge currents than surge protection devices. They are typically installed at the service entrance of a building or facility to protect the entire electrical system from incoming surges. Surge protection devices are installed at downstream locations to protect individual pieces of equipment or branch circuits. Another important consideration is the coordination of surge protection devices. Coordination refers to the selection and placement of surge protection devices in a way that ensures that they work together effectively to protect the entire electrical system. Coordination involves considering the surge current capacity, let-through voltage, and response time of each surge protection device. The goal is to have the surge protection device closest to the source of the surge handle the majority of the surge current, while the downstream surge protection devices provide additional protection for sensitive equipment. Proper coordination of surge protection devices requires careful planning and engineering. It's important to consult with a qualified electrical engineer to ensure that your surge protection system is properly coordinated. In addition to surge protection devices and surge arresters, there are other types of surge suppression equipment available. These include surge capacitors, surge reactors, and surge filters. Surge capacitors are used to absorb surge energy and reduce voltage transients. Surge reactors are used to limit the rate of rise of surge current. Surge filters are used to block high-frequency noise and transients. The selection of the appropriate type of surge suppression equipment depends on the specific application and the characteristics of the electrical system. It's important to consult with a qualified electrical engineer to determine the best solution for your needs. Remember, surge protection is not a one-size-fits-all solution. The best approach depends on a variety of factors, including the location of the equipment, the exposure to lightning, the characteristics of the electrical system, and the sensitivity of the equipment being protected. By carefully considering these factors and consulting with qualified professionals, you can develop a surge protection strategy that will effectively protect your electrical equipment and ensure the continued operation of your systems. Furthermore, it is also crucial to inspect the transformer itself periodically. Check for any signs of overheating, such as discoloration or bulging of the transformer case. Listen for any unusual noises, such as humming or buzzing, which could indicate a problem with the transformer windings. Ensure that the transformer is properly ventilated to prevent overheating. Keep the area around the transformer clear of obstructions to allow for adequate airflow. Also, verify that the transformer is properly sized for the load it is serving. An undersized transformer can overheat and fail prematurely. An oversized transformer can be inefficient and waste energy. Consult with a qualified electrical engineer to determine the appropriate transformer size for your application. In addition to surge protection and transformer maintenance, it's also important to address any other potential electrical hazards in the system. Check for any exposed wiring or damaged insulation. Repair or replace any damaged components promptly. Ensure that all electrical panels are properly labeled and that all circuits are properly identified. Install ground fault circuit interrupters, or GFCIs, in all locations where required by code. Provide adequate lighting in all electrical rooms and work areas. Keep electrical rooms clean and free of clutter. By addressing these potential electrical hazards, you can create a safer and more reliable electrical system. Regular inspections and maintenance are essential for identifying and correcting potential problems before they can lead to equipment damage or personal injury. Establish a regular maintenance schedule and adhere to it strictly. Keep accurate records of all inspections and maintenance activities. Train personnel on proper electrical safety procedures. By implementing these measures, you can create a culture of safety and ensure the continued reliable operation of your electrical systems. In conclusion, protecting pump controllers and other sensitive electrical equipment from surges requires a multifaceted approach that includes surge protection devices, proper grounding, transformer maintenance, and addressing other potential electrical hazards. By carefully considering all of these factors and implementing appropriate measures, you can significantly reduce the risk of equipment damage and ensure the continued operation of your systems. Consult with qualified professionals to ensure that your electrical system is properly designed, installed, and maintained. Remember, electrical safety is everyone's responsibility. By working together, we can create a safer and more reliable electrical environment.